All right, so here we're going to work on defining something called parent functions. And parent functions is basically a way to say a really basic function that does one operation and doesn't have really any additive or scalar multipliers in the problem. A couple of things before we do a couple of parent function graphs. Domain and range. Domain of a graph of a function is referring to all possible x values. Or in other words, you want to think, how far left and right is that graph going? So that's usually what I'll say when I'm finding the domain. I'll think to myself, how far left and right the graph is going. And you'll see there's exceptions to this, part in parentheses, but essentially that's what I'm thinking most of the time when I'm doing these problems. And likewise, the range is all the possible y values. And it's how far, you can say north and south or up and down. So how far north and south the graph is going. All right, and these will actually be introduced in a later lesson, but I always like to introduce them initially one time because it usually takes a little while for students to get this down. The first parent function we're going to look at is the absolute value parent function. Absolute value means distance from zero. A lot of times we mistakenly think it just makes everything positive, and that's not necessarily the case. Absolute value is distance from zero. The parent function equation is y equals the absolute value of x. And you can see they've already set up a nice t-chart for us. And typically, for a parent function, these are the x values we want to pick. Really simple ones. I've got -3 to +3 picked. If we take the absolute value of -3, how far is -3 from 0 on the number line? And of course, the answer to that is +3. The absolute value of -2 is +2. The absolute value of -1 is +1. 0 is 0 units from itself. So again, absolute value is the distance on the number line. So like, for instance, really quickly, if we had a number line and we have 0 right in the middle, -3 and +3 both have the same absolute value because they are both exactly 3 units away from 0. And distance, we know, is always positive. You can't be -2 miles away from somewhere. So that's why sometimes mistakenly we think absolute value makes everything positive. It did in this example, but just this will come up later on. If you get something like this, the absolute value of x minus 2, it does not automatically turn that -2 into a +2. That's just not accurate. It's not how absolute value works. And that's kind of what I mean, where it doesn't make everything positive. All right, so now graph those points. It is a V-shaped graph. It's mistaken sometimes with a quadratic because they're similar in shape, but this is a V-shaped graph, meaning it's made up of 2 lines that are increasing at a constant rate to the right. and to the left. That's again because numbers to the left and right of 0 have equal distances from 0. Our domain is how far left and right this graph is going, and you'll notice I have a left arrow and a right arrow. Well, if we imagine this graph, if it just kept going, it's going up, but it's also going to the left forever. And this arrow over here is also going up, but it's also going to the right forever. So since it's going left and right forever, what we're going to say is we're going to say the domain is all the numbers from negative infinity to positive infinity. Looks kind of like an ordered pair, interval notation, but that's how we write it. The range is how far north and south the graph goes. And again, there's exceptions to that rule, but not if it's a continuous function. And that's all we're seeing for right now. So the range definitely, like we just talked about, is going up forever on both ends, but it's not going down forever. It stops right here. It has a lowest y value, and the lowest y value is at 0. You'll notice we put a bracket around that number because we include that number in the range. And then it goes up forever from 0. We never put parentheses around infinity because you can't contain infinity. The x and y intercept, again, we'll talk about this in a later video, but it is 0, 0 for both. All right, and then finally I defined what an absolute value function is. We talked about this, but it represents various numbers distance from the center of the graph. A lot of times we say distance from 0, but it's only the distance from 0 in this case because the vertex is at 0, 0. So sometimes that vertex can get shifted. So the distance is not necessarily the distance from 0, but instead it's the distance from the center of the graph. All right, the next parent function is the quadratic function. We've talked about this one already. So quadratic function is simply just an xy relationship where y is equivalent to the square of each x value. So we know that to get the y value, we're just squaring -3, we're squaring -2, we're squaring -1. Of course, when we square a negative, we always get a positive. When we square a positive, we will always get a positive. So that's why this graph is really similar, but not exactly the same as an absolute value graph. Essentially, it just increases or decreases at a quicker rate. Of course, we know the shape. We talked about this earlier, but that is a parabola shape. So domain is how far left and right the graph goes. Sometimes this can be tricky because, of course, these two arrows are going up forever, but we also see that they are very slowly moving away from the vertex or the center of that graph, and they are moving left and right forever. So that means our domain, again, negative to positive infinity. That will always be true for quadratics and for absolute value functions. And then likewise, the range will never be negative infinity to positive infinity. The range is how far up and down we go, and of course we're going up forever, but we have a lowest point, and that y coordinate is at 0. So our range goes from 0 to infinity. Again, our intercepts are just 0, 0. The main thing we want to focus is just making sure you can fill in a basic t-chart for these 3 parent functions. And the last parent function is the radical or square root function. All right, so a radical or a square root function is an xy relationship where y is just the square root of each x value. And sometimes it's called the broken function because it kind of looks like just a part of a graph. But that's because, of course, we can't take the square root of -3 using real numbers. The square root of -3 does not exist, so I'm going to put D in E. Can't take the square root of any negative number. And that's because there's no number, when you multiply it by itself, can still give you a negative. The square root of 0 is 0. The square root of 1 is 1. Now the square root of 2, I don't really know what the square root of 2 off the top of my head is, but if I pull out a calculator, I can type in the square root of 2, and I see it's about 1.4. So I could use that number, but typically, if we can, we want to stay away from decimals just because they're really difficult to graph. So what we want to think about is, okay, what is the next perfect square after 1? About 4. So 4 will be the next number in our square root chart, and that's because the square root of 4 is 2. And notice how we're just increasing by 1 here in the y column. So then this last number, we can make a 9 because the square root of 9 is 3. And we're going to graph those 4 points. We can't really graph any more points without going way off the graph there. So there's our function. This is an inverse function of a quadratic. So when we list the domain, this is our first graph that does not have a negative to positive infinity domain. And that's because it has a leftmost point. It doesn't go past this point. It doesn't go to the left there of the origin. So that means the domain starts at 0. And we're going to put a square bracket around 0. But it is moving to the right forever. And then similar with the range does not go down forever. The lowest point is again 0. That happens a lot with parent functions. And then you got to ask yourself, is this going up forever? And the answer to that is yes. It's just going up forever really, really, really slowly. So the range 0 to infinity. X and y intercepts are both 0, 0. So that is what it looks like when you graph parent functions using a t-chart.